Welcome to Learn Yourself. Today we are going to understand pressure in fluid and buoyant force. These topics are under CBSE Standard 9 syllabus from the chapter Gravitation. So fluids, what all are the fluids? The liquids are fluids because they have a property to flow. That's why we term them as fluids. Now three states of matter are there: solid, liquid and gas. They all possesses mass. They all exerts pressure. But situation is little bit different when we are talking about fluids, because fluids or liquids we are filling into a container, and when we are filling them into a container it exerts pressure to the wall of the container. So here we are going to discuss how fluids are exerting pressure on the container or any specific object, in what all direction, and how they are exerting a force. So pressure in fluid, liquids have weight and they also exerts pressure on the base and wall of the container. For example, this is our container and we have filled a liquid or a fluid till here. So it exerts a pressure to the base because it will always lie at the base. Now it also exerts pressure at the wall. Till how much we have filled this container, it exerts pressure in all the direction till its surface. Till its surface. Pressure exerted by mass of the fluid. How much ever you have filled the fluids into that, this pressure is directly proportional to the mass of the fluids. Is transmitted undiminished. Undiminished means without getting zero. Diminished means almost zero or almost negligible. So it is transmitted. Transmitted means it is transferred, undiminished, without negligible value or without getting diminished, in all direction. So it exerts pressure in all the direction on the wall. Now when fluids are exerting pressure on the object or on a container of the wall, that force is termed as buoyant force, and this phenomena is known as buoyancy. So now let us understand more about buoyant force and buoyancy. To understand buoyancy, let us understand one activity. So this activity is based on an empty water bottle, empty plastic water bottle that we are trying to immerse in a water-filled container, and we will see that what will happen, and with series of this situation we will get to know and we will try to understand the buoyant force and buoyancy. So here this is one empty plastic bottle and this is one water-filled container. I am immersing this plastic bottle to deep inside the water container. I am applying certain pressure so it will go down and it touches the bottom of the container, and then I am suddenly releasing pressure what I am applying to that of the plastic bottle. Plastic bottle is empty. I haven't filled anything into that. So it is lightweight. So to immerse into that I have to apply some pressure. Now as soon as I am releasing my pressure, it will bounce back till the top of the water and then it will float on the surface of the water. Now let us understand as per the buoyant force and the scientific phenomena which happened over here. Now we all know that each and every object has certain weight, and this weight is due to the gravitational force of earth acts on them. So when we are immersing this bottle and we are applying pressure to this bottle, along with that the gravitational force of earth is acting on that, so it should remain at the bottom. But when we are releasing this pressure, it jumps out and it comes back. So what is happening? That here fluids also exerts pressure on the object, and that will be in upward direction. That will be in upward direction. This is known as buoyant force. So fluids also exerts pressure on the object and which will be in the upward direction. Now when we are immersing this bottle at the bottom, till the time I am applying pressure on that, so my pressure will be equal to the buoyant force. Whatever pressure I am applying to the bottle, and bottle will remain at the bottom because it balances the buoyant force which is applicable on the bottle, and the direction of the buoyant force will be upward. So till the time it balances, it will remain inside. As soon as I am releasing the pressure, the buoyant force will overcome the gravitational force and weight of an object, because we know that the weight of an object is very light, even though the gravitational force is act on them and the weight will be more because of the gravitational force, but the buoyant force will overcome that weight of an object, and because of that buoyant force and because of that fluid pressure which is acting upward, this bottle will comes out and it will float on the water and it will float on the surface. Now all the objects which are remain in the fluid or on the surface of the fluid are experiencing this buoyant force, and this phenomena is known as buoyancy. So this is the reason that why a huge ship can float on the surface of the water. How much buoyant force will be applicable on the object, that is depending upon the density of the fluid. So as the fluid is more denser, the force which is buoyant force, and that will be on the higher side. So as fluid will be denser, the buoyant force measure will be higher. So let us understand this. Earth's gravitational force will be applied on the bottle in downward direction, and that is the measure of its weight. That is weight. That weight and gravitational force is acting towards the down. So weight of an object is due to the gravitational force, and gravitational force is acting towards the downward direction. But water exerts upward force on the bottle. This upward force is upthrust or buoyant force, is known as buoyant force. So whatever force exerted, we are applying pressure or the gravitational force which is applicable on the object. So force exerted, that means the water exerts force on the bottle that will be greater than that of the weight of a bottle. So weight of a bottle is a product of mass and the gravitational force. So that will be lower compared to the force exerted by the water. So here buoyant force is higher compared to the gravitational force and mass of an object. So in that circumstances and in that situation, the bottle will come out, because the force which is applying upward is higher compared to the force which is applying downward, that is lower. This is due to the gravity and due to the mass of an object which is applying downward, whereas here this is a buoyant force which will act towards the upward direction. That is greater, so that's why the bottle will bounce back towards the top of the water and it will float on the surface of the water. Upward force exerted by fluids on object is known as buoyant force, and this phenomena is known as buoyancy. And because of this reason, larger ships can sail on the water or in the ocean. Now let us understand these two reasons that why object floats or sinks when placed on the surface of the water. Here we are taking two objects. One is a cork and one is a nail. Cork's weight, we all know that it is very lightweight, whereas nail is heavy compared to cork. So when we are keeping the cork on the surface of the water, it will float. But when we are placing a nail on the surface of the water, it will sink. So what is the reason behind that? So here the density will come into picture. What is the density? Density is mass per unit volume. So density of the cork is less than that of the water. So upthrust of water in this case is larger compared to the weight of the cork. So when we are placing a cork on the surface of the water, the upward force, which is a buoyant force, it is also known as upthrust of water, will be higher in upward direction compared to the mass or the weight of the cork. So weight of the cork will pull it downward because of the gravitational force of the earth. but the upward force is higher on the side and it is pushing it upward. So here the upthrust force of the water will be greater. So that's why cork will float on the water. Now what will happen in the case of nail? The density of the iron nail is more than that of the water. So because of that, upthrust of water will be less compared to the weight of the nail. So weight of the nail is pulling it downward because of the gravitational force, but the upthrust force is pushing it upward. But here the upthrust force or the buoyant force is lesser compared to the force which is pushing it down. So that's why it will remain at the bottom of the container and it will sink, whereas the cork will float on the surface of the water. It is always depending upon the density of the object. If density of the object is more compared to water, then it will sink. And if it is less than that of the water, then it will float on the surface. Now let us understand one more example about buoyant force and try to understand that if any liquid is applying upthrust force to any object, then what will be the measure of that upthrust force? That means how much upthrust force will be applicable to any object and how to find that. So here we have taken one stone and we have attached this stone with elastic string, and we can see here this string has been elongated because of the weight of the stone. This is a container which is filled with the water. Once we are immersing this stone into the water, we can see that the elongation of the string has been reduced. Elongation of the string has been reduced because of the upthrust force of the water, which will make the weight of the stone lighter, because gravitational force is applicable towards the downward direction, but the upthrust force, which is buoyant force, is applicable towards the upward direction. That will make the difference of these two, that gravitational force and buoyant force, difference of these two will make and how much this object will become lighter. So difference of gravitational force and upthrust force will tell us that this much will be the object will become lighter when we are immersing it into the water. Now what is the meaning of this? The meaning of this is that this much upthrust force is applicable on the object, and that is how much object has replaced the mass of the fluid, or how much fluid has been replaced by the object. That much upthrust force will be applicable on that, and this idea we will get from the Archimedes principle. It says that when a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. Whenever we are dipping something inside, so here you can see that the surface of the water has come up because that much volume has been covered with the stone and that much water has been displaced by the stone. So how much upthrust force will be applicable to the stone? How much it has replaced the fluid, and that fluid which has been displaced by the stone, and the stone is displacing fluid. So this fluid, this liquid, the weight of this fluid, how much the stone has displaced, will be equal to the upthrust force of the water. So how much water will apply the upthrust force to any object, that once the object will dip inside partially or fully, so how much it is displacing water. The weight of that displaced mass of the water is exactly equal to the upthrust force applicable on that object. So if the object is bigger in size and it is displacing more of a water, then it is experiencing more buoyant force. And if the object is smaller and it is displacing less water, then the upthrust force applicable on that will be smaller. Now why we are using density to check the purity of any substance? So what is a density? Density is mass per unit volume. This is a definition of density. So density of given substance under specific condition remains the same. So density of substance will never change, and under specific condition it will remain constant. Because it remains constant and it is specific for each and every substance, it will become a characteristic property of a substance. So if you want to check whether this substance is pure or not, then you can check its density. And you can refer the data which says that the purest substance density is this much, and you can compare the practical density with the theoretical value. Once these both values are equal, you can say that whatever substance you have, that is purest in its form. Always we are checking density with respect to water's density. We know that water's density is 1000 kg per meter cube. So any substance density, we are taking a ratio of that substance density to that of the water's density, which is 1000 kg per meter cube, and that ratio will give us the relative density of any particular substance. So if in case there is any impurity into the substance, then it will not matches along with the theoretical value or correct value. So it will tell us and it will indicate that this substance is not in its purest form. If this value equals to the theoretical data, that means that that substance is in purest form. And based on this and Archimedes Principle's application, we have designed a lactometer. Lactometer is used to determine a purity of milk. So that is again based on Archimedes Principle, and to check purity from a density of any particular substance. Now let us understand what is relative density. Density of a substance is a different thing, but when we are talking about relative density, so relative density is a ratio of density of any substance divided by density of water. So density of water, we know that it is 1000 kg per meter cube. So for any substance density, if you know, then once you are taking a ratio of that substance density to then that of the density of the water, then this density is known as relative density. And this relative density has no unit. So relative density is equals to the density of one particular substance and divided by density of water. In coming videos, we are going to discuss many important concepts. So don't forget to subscribe, Learn Yourself. I'll see you in next video. Till then, keep learning, keep sharing.